So I just started the recording. So I will start to talk about my journey to transparency and reproducibility. So it's been quite a journey, and I will first start by saying, who am I? So I'm obviously not Iron Man, sorry guys. I'm just a simple guy with a PhD in biostatistics, and I'm leading a small team of statisticians in a research laboratory working mostly on metabolic disorder, such as type 2 diabetes, obesity. And one of part of my work is basically to develop tools to support the research. So I developed and contributed to different packages on CRAN or on GitHub. So as you can see, not all those packages are really useful to do science and discover new things. So where did I start it? Well, when I first arrived in the lab and I connected to the server, a project looked like this. So if you are not familiar with those type of data, PLink is a type of genetics files to store like a genotypes and things like that. So as you may see from the extension, there is some log files, some other file, some text file, some folders, some file without extension, so we don't know exactly what it is. So I said, okay, yeah, let's dig a little bit and try to find out. And actually, that was not the only project with that kind of architecture. Here we have some scripts, some text files, some temp directory, and Perl scripts, R script, and it was going on and on like this. Like how can someone do science here? Like what is the first script to run? What is the actual raw data? What is the generated data? So basically a nightmare to work with. So the idea was to put some project structure. So yeah, let's look at it. So a simple thing that can be done basically is, okay, let's be organized a little bit. Let's have a data folder, some documentation folder, a README, because yeah, arriving into a project with a README, it's really nice to actually see what it is about, some maybe reports, and obviously the script you need to do the actual analysis. So that's one part of the issue. So now we have a little bit of structure, so we can see a little bit more like what it is about, where you can find the documentation, the script. So a little bit more transparency here. The second part of the issue was there was redundancy, different version of the same script over and over with some minor change. Sometimes it was only in the name of the file. So the idea was to add something that's obvious maybe for many of you, was to add Git and some version control. So at first, it hurt a little bit, let's say it. But in the end, it was like a lifesaver, possibility to go back to a previous version without having to have actually like this here, 3 versions of the same script. So now we have kind of something which is easy to work with, but actually we can't do whatever we want. In my lab, we're working with different servers, so we are completely relying on system infrastructure. And we have a main server, we have different users, and you might think like, okay, so if we want to do whatever we want, like we can have R, Python, or Perl, or whatever language you want on your computer and work with it, and maybe send something to the server. So that's nice, but that means actually if you work only on your computer and don't make your environment isolated, it's not portable. You can't share your code to anyone else and it won't work that great. And worst, in my lab, actually, it was more this setup, meaning the R and Python was on the server, and actually our computer was not was only an access to that server through SSH at first. So here we have basically a one access point, one server to do everything. So that's not nice because we were not root users. So we were not able to install R packages, like system libraries. So really hard to work with. we always had to ask an IT to like, I need these new packages, could you install it? Some might say, okay, but you can install it in your home folder. Yes, that's true. But actually, our home folder was not that big. It was just a few megabytes. So when you work with genetics data, you might want to download some bioconductor packages, which are like sometimes 1 gigabyte. So you can't actually do that. And anyway, it's not the right place to install packages in your home, because your home is your home. So you can't share it to anyone else. And this simple ID is against the reproducibility ID. So our setup was basically lacking different things. So the same code was not able to actually work on different machines, computer and everything. So it was completely designed to work with that particular setup. So in a way, it's nice, but it could be better. Once we wanted to install a new packages, since it was at the system-wide level, that means any project using that packages will be impacted, and not necessarily in a good way. So like, we really needed to be cautious when we wanted to have something new on the server. And even from the IT side, it's a nightmare to handle because they don't have like a recipe to follow to install things. So it was like really manual install. So really hard to work. And actually, if there is something that that broke down from the server, that means like there is absolutely any chance that you will get the same setup again. So not really great. So the idea was to use Docker. So if you are not familiar with Docker, it's a way to have some kind of virtual machine embedded, and you can build whatever machine you want. So it could be a Windows machine, Unix-like, Mac OS. It's basically whatever you want it to be. So to do a Docker image, then a Docker container, you need to have some kind of recipe. And actually, it's really a recipe. You have what is called a Dockerfile, which actually states every step you need to perform to install and to prepare your machines. So here, for instance, it will be like, okay, I'm working on a Debian with the Buster version. There is some environment variable. I want to install, for instance, some system libraries. I want to install, like, obviously, R. So here, I even have an environment variable which say like, okay, I want the 4.0.3 and different things. So here I had also a setup to actually install a lot of R packages that was used in my lab. So I don't list the file here, but it was like a few hundred packages. And at this time, now we have a system that is a little bit more flexible. So it's nice to have something a little bit more flexible. We can install packages, we can remove them, and we have something that actually track everything. The other part here was, okay, we wanted to have a setup, a structure for each project, but actually where we are doing it again and again and again. And since it's always the same thing, there is a way to actually make it that easier. You can work with a RStudio project template. So it's designed as a R package. And with that, you can use the RStudio IDE to actually create project based on a simple R function that will create the folder and everything you want. So obviously, I created an R package to do that. And first, the R package created just that simple structure with a README, docs file, logs file, output, report, and script. So now we have the system which is more flexible than before. Not perfect, but it's there. We have a structure. So the idea, okay, but yeah, there is an issue here. When we use that container, we are using like more than 100 R packages and all the dependencies behind. Meaning this kind of Docker images was way big, like 10 gigabytes of data to actually download if we wanted to deploy it. So not really great. And actually, we did not remove the fact that, yeah, it was not possible to install new packages at the specific version. It was completely frozen within the Docker container and not at the project level. So, okay, we saved the version, but we are still lacking some flexibility. And that's basically here what I'm saying is, okay, we have a structure with some folders and things like that. We have more flexibility at the system level using a Docker file. So we can define as many Docker file as we want. The Docker file is completely reproducible, or nearly, because it still relies on some repository for the libraries. But mostly it's reproducible because once you have built a Docker image, that image is completely frozen. So meaning in 5 years, that same image will be exactly the same. And you can deploy a new computer with that, a new container, and it will be exactly the same system as you built before. So in that way, we are reproducible. The less good is, okay, you still need some knowledge about system administration because as you may have seen in the Docker file, it's only bash commands. You need to do apt-get update, install. So you need to know that stuff to actually make it work. So a bit of work for you to do. There is no way in that setup to actually install interactively new packages, at least if you want to keep it reproducible. And it's not at all project specific. So still the same issue as if we want a new packages for one specific project, but not for the other, that doesn't really solve that issue. And one of the issue, but I think it's not totally true since recent update of Docker, at least it required to be root, meaning you need to be a root user with any access, full access to everything on the server to actually run a new container. That is not a good idea for security reasons, because if you have a new intern, you don't want that intern to get selectively full access to every data, including sensitive data. So what if there is a way to actually keep that environment for the system-wide, but completely remove the R package thing? Okay, I didn't know. Thanks, Gerald. Let's keep like the root thing argument for the sake, at least, of the presentation. So here, what if we have a way to actually install R packages and Python and actually record every version of those tools, and without actually being on the system wide, meaning you can install those and record version at a specific project. So that would be nice. And actually, it's possible. And the first time I heard about this R package, which is called renv, it was like exactly like this. Like I was just amazed. So renv is basically help you create a reproducible environment. So it's allowed you to isolate your code as you isolate your libraries, including some system libraries. It makes it portable, meaning you can just grab your whole project, put it in your archive, and send it to anyone else. It will have the same setup as you, besides the system. And it's obviously reproducible because you will have the exact same version of any R software, Python module, and your script. So it seems like really, really promising. So here are all the functions to date in this R package. So I won't show everything because, yeah, there are a lot of functions, just a subset of those. So few functions just to activate, because you don't want necessarily to use only your local R packages within the project. So with RAM setup, you might want sometimes to deactivate it, activate it. So it's possible with a simple function. There is a main function, which is the init function. It's the function actually is a major one, which initialize your project, scan all your R script and other script to find where are the packages you need and what are they. And if Ramp finds some packages, he will try to install it. So install it in a special library, which is local to the project. You can install packages with install. So Hydrite is the function that actually does the scanning. So including R Markdown script and R script. Any call to a packages as a prefix or with a library require will be detected by Hydrite, meaning you can save time because like here you can actually get all your packages from one project in one go using that function. Sorry. There is remove in case you want to remove the packages. Snapshots, which allow you to actually take a snapshot of the version of all the packages you are actually using and really using. So that's the default setup. You can update packages because sometimes you need to update only one package, so you can do that with Ramp. And one feature which is really nice is the restore function. So will a version of the same package be installed for each new project? So I will go to that question in a demo just after that. So you will see like actually Ramp is a powerful tool. So just to go back for the last function, restore, which allow you to actually restore all the version of a package you saved previously with a snapshot. So as I was just saying, I will try to show you how it works and what is the good from that package. So hopefully it will work. Just a quick, it's supposed to work, but are you seeing my RStudio right now? Yes, perfect. Thank you. So here, simple IDE. So you don't have actually to use RStudio. You can use whatever you want. It's just like here easier because it was designed to work well with those packages. But that's all. Okay, I will zoom a little bit here. Okay, I think that should be enough. So here I have my little demo project, which is basically a single script and some default RProj folders and a gitignore. So this project and the script is in my GitHub, so I will send it after the presentation. So you can just load the Ramp package. I will just load an extra package on purpose, which is in my demo here, which is FS for file system. And it's just an easy way to actually get the structure without having to click everywhere here. So the first function when I was saying is the init function. So Ramp make it really clear about what is going to happen in your project. So you have a lot of text saying that he will store some cache for the installation, and he will just tell you where. So it will depend, and by default, it will be on the user folder. So either in your home folder on a Unix Slack system, or here in your app data folder in your user account in Windows. There will be different details here, and actually what are the changes that Ramp is going to perform. So I will just say yes, and because I read it a lot of time. So here, there is different lines. The first is created the architecture and the cache structure here. Then he initialized the project, and there is the discovery steps. So basically, he scanned, including the script, and saw that there was a library here that called Ramp and one that called file system. So what he did is basically he downloaded it and already added to what is called a Ramp here .log. So this is a JSON dictionary with all the information regarding your current setting. So here he restored everything. I will just show you first the architecture that comes with that. So after Ramp initialized everything, he created that structure. So we have now a library within our project, so within the Ramp folder, We have the version for R, the subsystem. So here it's a Windows one. Here, file system says that actually the CLI, FS, GLUE, prompt are present, but actually the color has a significance here. It means actually they are symbolic link. They are not actually the packages data. The only actual packages right now is this one, because you need actually to have RAMP in your project to make it work. All the other packages by default are just using some shortcuts to get to the cache. So meaning you can share the cache across different projects. So that's a nice feature because like most of the environment, if you share the same setup, so in my lab, we are different users sharing the same server. We don't want to have like our own cache. So we have a shared cache where everyone that actually install a package will download it through that same folder, meaning this folder will be available to everyone to actually speed up the things when we want to install packages. So here we have that structure, and I wanted to show you the RAMP file. So the RAMP a JSON file with the first part describe what is the R setup with the R version, what is the repository for the CRAN used, the backup one, so you can have even MRAN or whatever you want, some local snapshot of the CRAN. And after that, you have the list of all the packages installed. So here, RAMP detected only 2 packages, RAMP, the one installed, and file system here, FS. So you have different information where it was from, the version that was downloaded and installed here in that project. So all the information you might need in the future to actually make it work again. So that was the initial setup. So here I will just trick a little bit the system because I'm under Windows and I know for a fact that on my computer there is an issue with the default download method with RAMP. So I want to change the download method and use libcurl. The trick is I don't have libcurl on my Windows. And RAMP is smart because here libcurl is a parameters for RAMP. We can use RAMP equip, which actually will try to find all the system dependency, system libraries and dependency you might need. So here, there is a list of some archive files which are going to be downloaded into the cache in a xsoft folder. So it takes just a few seconds to download. And this way I will be able to actually download through HTTPS the packages using RAMP. So in most systems, you don't have to do that. It's just here for the sake of the demo and because I know that it's not working well on my computer. So now we have the libcurl library installed. We can just try to do a snapshot here. And the beauty is we didn't add any new packages. We didn't use any new packages and call any new library thing. So the log file is up to date. So that's nice. That means, yeah, apparently everything is recorded. So now we can install packages. So there is 2 ways to do that. Actually, RAMP masks the install packages. So you might want to use this one. And as you can see here from the namespace, it's not the base one. So meaning, even if you like forget that you are in a RAMP setup and use a default install function, it will work well. It will install with using the cache and everything. So here for the install, I'm just going to install Erlang because it's a small one. So it's downloaded it. Now I have it. And if I install it again, you can see that it just linked to the cache. So it's faster. You can use the cache to actually speed up installation over different projects on your laptop or either server. Yes, this session is recorded and will be on YouTube. So you can see the version here. So it's a different one. We can install other version of any packages. So let's say we wanted the previous version of Erlang. You can do it by using the @ symbol and the version number just after that. So if we run that, it will go to here, the Enron snapshot, and try to find the latest corresponding version. So here I have an obvious conflict because Erlang is used by RAMP and other setup in RStudio. So I will just restart it. So now the project RAMP was loaded automatically here. So I'm in my environment, and I can look now at the Erlang version. And now I can see that, okay, I have my version I just installed, which is the 4.9. And you can install the same packages from GitHub and even from Bioconductor using just this simple prefix. So that's quite powerful because in one go, you can install old packages, new packages, development packages, packages from Bioconductor, basically everywhere. So now we installed a new package. So we want this package to be recorded in our session here. So what you can do is just check the status of your project. And as you can see, we install a new packages, which is Erlang. And when we call run status, it says like everything is fine, you don't need to do anything. Yeah, but I just installed a package. By default, RAMP actually wants you to be explicit. If you want to record a package, it has to be called somewhere explicitly. So let's do that. I will just write library Erlang to a random script here. And if I run again status, now I have something that appears. It says like, okay, there seems to be a package that is actually used, but not yet recorded. And RAMP tells us like, maybe you should use a snapshot here. So I can just simply run a snapshot. And you have this particular syntax, which is you have an asterisk and the version. So 0 tells you that actually you are going from nothing to something which is a version 0.4.9. So you can say yes. And if you are not really confident about like what happened, you can get back to the ramp.log file. So we are still our two first packages, fs and ramp. And now we have newly installed and recorded package, which is Erlang, which is like it was from CRAN and this version. So now we are happy. That means we install the packages, we use that packages, and we have saved the version we want. So the two functions to deactivate or activate RAMP. So if I deactivate it, RStudio will restart automatically the session. And now, basically, I lost the access to the local library, but at any point, I can just reactivate it. So here, we have this header that appears that actually tell you that, yeah, you are in a RAMP environment, meaning you have access to a local library with packages, not the system-wide libraries. So it's a setup, so you can actually allow to have access to system-wide libraries from within a RAMP project. But in that case, your project is not anymore completely isolated. So one of the main, actually, feature, in my opinion, is the restore function. So to do that, I will just completely erase the current library. So if I'm looking back here, I don't have the library anymore, meaning I don't have Erlang anymore. If I try to call Erlang here, it doesn't exist anymore. So imagine you have a lot of packages, a project which is new, and you want to actually restore everything that was recorded in your RAMP log. It's quite easy. You just have to run the restore function in the project where you have already the architecture with RAMP. And if you do that, you have a pretty message that say like, okay, apparently you have a RAMP file with 3 packages. They are not present. And do you want to install those? So I'm going to say yes. So he installed a new package. So here, the 4.9, because by default on my system, I'm using the latest. So that's why here we have again the conflict. And now, if I'm looking again, I basically got back the different files. And if you really want to actually isolate your project, so there is the isolate function, and the isolate function actually take all the packages that are in your cache and replace all the symbolic link into your library with the actual packages, meaning your project will be bigger in size because you will have all the packages needed in that project. But so according to your setup and what you want to do, that could be a good idea, because this way you know that actually your project is really portable. You can just put it into another computer. You will have all the R packages needed. So time to go back here. So that was like just a quick overview about what RANV can do and how it can help do more reproducible project and script, or even development. And you can use that with a Docker, for instance. You can use that to build a new container. Just take your RANVlog file to actually do the main setup. So you can record every packages in one RANVlog and say that will be my default set of packages for any container I will build. And you can just execute here within a Docker file this command to actually install all the recorded version from that file. So it's a nice feature because now it's easier to list a lot of packages with different versions and to install those quite easily. You can use it to actually run an analysis. So there is different ways to do that. As you see in my demo, there is a header that appears when you are in a project with RANV. So it's called the autoloader. The autoloader thing is a .rprofile script present at the root directory of your project. So if you want to avoid that from being loaded without your consent, you can just use the vanilla option when you run a R script and get into your project and still work with RANV and restore file and run your script. So meaning you can actually have a system which is based on Docker, and preferably with a Docker file, which lists all the system commands you want to use. You can have a complete dictionary of all the version you want to use with R and Python. And you can have still your script from the project. So you have basically everything you need. With that setup in mind, I updated my Docker file and said, okay, now I don't longer need to have more than 100 packages, which in reality was more like 1,000 packages, counting on dependencies. So I can just squash a little bit the number of packages and do only few ones to work on a day-to-day basis, so data tables, tidivers, and things like that. Doing so, I also improved my R packages to do the setup for a project. So now, as you see, it's bigger. There is more detail. There is the RANV setup. So I didn't show you the demo because I don't have Python on my computer, and it's take a little bit of time to install. But if you set up Python, so it's quite easy to set up Python with RANV. There is a use Python. So just use that command and it will create all the directory structure you need to have Python. And it will use either the virtual environment from Python or Conda. So it depends on what you want. You can have one of those, and it will create this requirements text file, which will record all the Python module you have in your project. So it's quite nice if you work both with R and Python. So now I have my R packages, a smaller Docker file, a smaller Docker image built from that Docker file. When I say smaller, it was decreased from 10 to 2 gigabytes. So it's definitely smaller. It could be smaller. But now I have actually a system which is more close small. I have a project setup that actually is more flexible, but still reproducible. So really nice. So that's the main pros and cons here. So yeah, the argument about like that Docker required to be root, it's not the case anymore. And in the chat, someone told me that, yeah, there is some option now to actually do not have to need that. So I will have to look a little bit more, but the other argument about like having knowledge about administration and the system, like you still need to know bash commands and things like that to install system libraries and basically to build a Docker file. So that's less good for beginners. So one of the solutions for that, actually I used in my lab, is I have different setups. So we are all root users, so we can run any container. But for like beginners or interns, especially, I have a Docker file that actually creates some kind of development environment, which is based on the RStudio server software. So the intern actually have access to the IDE through the web browser, and actually it's based on a Docker behind. So it's completely transparent for the intern. It has access to everything on the project. It can install packages using Ramp. So really nice. It doesn't have to know anything about actually Docker or any system commands. So that's really nice. Another thing we are working on right now is to use Singularity. So Singularity by default does not use root privileges. So that's a plus. And actually, the main argument here is most of the computation grid, especially in the academic sector, are using Singularity. So it will be easier to have a system that use the same thing to actually have a backup if we need to. So now to conclude a little bit, so the next thing to improve reproducibility and transparency would be like to switch to Singularity to avoid any security erosion, but also like to use, so that's the main focus right now in my lab since a few weeks, is to use the targets package. So if you are not familiar with that package, it's a make-like pipeline, which allow you to define different stems, which are steps in your analysis. And this package will actually save metadata and data to know if your task is up to date, not up to date. And it will basically save a lot of time and make your pipeline actually nice. So here is a simple screenshot about a network from a target pipeline. So that's the next thing we want to use to improve everything. And that's all for me.